So based on their positions, which of these has the smallest atomic radius? So the trends in atomic radius is as you go down and to the left of the periodic table, atoms get larger. And that's the general trend. There are exceptions. So the answer we're looking for is up and to the right because it's asking us which of these is the smallest. Right, if we identify where these elements are, magnesium is there, strontium right below it, silicon, chlorine, and iodine, they make a nice rectangle, so it's easy to see which is highest and to the right. So your answer is going to be chlorine. Just give you a little reasoning behind why chlorine is the answer. As you go down the periodic table, atoms generally get larger because they have more energy levels of electrons. So those electrons are farther away from what they're attracted to. And not only that, when you have, so here's the nuclear charge, what's attracting those electrons. When you have an energy level full of electrons, those electrons repel or shield the electrons outside of them, which shield and repel the electrons outside of them. And so the more energy levels you have, the farther those electrons, those valence electrons, which is used to measure the radius or the size of these atoms, they're just farther away. Now as you go to the right, atoms get smaller generally. And the reason for that is those electrons, which are attracted to the protons, are at the same energy level. So let's say n equals 2, but by the time, well, as you go progress to the right, the nuclear charge increases. And so because there's more charge in the nucleus attracting this same energy levels of electrons, they're going to pull them in closer to the nucleus, which is why atoms get smaller. Right, so they get smaller going across because of nuclear charge increasing, and they get larger going down the periodic table because n increases, which means also the shielding increases.